We spend so much time on apps like Instagram just scrolling away. But have you ever actually stopped and wondered what's going on behind the screen? It's not magic, I can tell you that. It is a massive, incredibly complex machine. So today, we're going to pull back the curtain and look at the actual engineering blueprint that makes a social media giant like this tick. It's a huge question, right? Because building an app that can handle millions, even billions of people all using it at the same time, well, that's not just about having a cool idea. It's about having an incredibly solid plan. So let's start right at the beginning. Before you even think about writing a single line of code, you have to define the challenge. You can't just start building a house without a blueprint, and it's the exact same thing here. We need a crystal clear set of requirements. We need to know exactly what we're building, and just as important, how well it needs to perform.
And those requirements, they really fall into two critical camps. On one side, you've got your functional requirements. Think of these as the what. What does the app do? You can create a profile, post a photo, like a comment, all the features you actually see and touch. But then, on the other side, you have the non-functional requirements. This is the how well. It's the promise that the app will be super fast, that it won't crash when you need it, and that your data is always safe. You absolutely need both to succeed. Okay, so with our requirements locked in, we can finally start drafting the architectural blueprint. This is our high-level map. It shows how all the different parts of the system are going to connect and talk to each other to deliver that smooth, seamless experience we all just expect. So everything kicks off right there in your hand, on your phone. That's the client. When you do anything, like refresh your feed, the app sends out a request. But that request doesn't just wander out into the internet. No way. It has to go through one single, secure front door called the API gateway. You can think of it like the main lobby and the security desk for the entire operation. Everything has to check in here first. Once a request gets past that front desk, it's directed to the real brains of the whole operation, the backend services. Now, instead of one giant program trying to do everything at once, a modern system like this uses a team of specialists. Each of these services has one specific job that it does, and it does it extremely well. And here's what that division of labor looks like. When you log in, the auth service is the one that checks your password. Simple. When you decide to follow someone, the user service takes over and updates your social connections. And when you're scrolling your timeline, that's the feed service doing all the heavy lifting to pull it all together. It's a really efficient, organized team where everybody knows their role perfectly. And of course, all these busy services need a place to store and retrieve information. That's the final piece of our blueprint, the storage layers. You have databases, which are kind of like these hyper-organized digital filing cabinets for all the user info, posts, and comments. And then you have object storage, which is like a massive, secure warehouse for the actual files, every single photo and video you upload. So let's zoom in a bit on those filing cabinets. Because the way data is organized, what we call the database schema, is absolutely fundamental. I mean it. If the data isn't structured correctly, nothing else works. It's the foundation that every single feature is built on top of. It all starts with the users table. Pretty straightforward, right? Every single user gets their own unique ID, and we store their username, bio, and other key info right here. This is the central record for every person on the platform. Okay, next up, the posts table. Now, the absolutely crucial piece here is that user ID column. See how PID 101 is linked to UUID 1? That's the magic link. That connection right there tells the system that the user, Anita B, is the one who created this specific post. Every single post is tied directly back to a user. And this is how the social network actually gets built. The follows table looks almost too simple, but it is so powerful. This one little row tells us that Charles is following Anita. The entire social graph, with its millions and millions of connections, is really just a gigantic collection of these simple two-part links. All right, now for the main event. Let's see how all of this comes together to build the single most important feature of the app, the feed. Constructing your personal timeline and doing it instantly is one of the biggest engineering challenges there is. Getting it right is the key to a great user experience. So there are two main ways to tackle this problem. The first is called fan out on read, or you can think of it as a pull method. When you open the app, it quickly pulls the latest posts from everyone you follow and builds your feed right there on the spot. It's simple, but imagine if you follow 1,000 people. That could get really slow. The alternative is fan out on write, or push. When someone you follow posts something, the system immediately pushes a copy of that post into a pre-made feed that's just waiting for you. This makes reading your feed incredibly fast, but it creates a ton of work for popular creators with millions of followers. So what do real-world systems do? They get clever. They use a smart hybrid approach. For the vast majority of us, that simple pull method works just fine. But for the celebrities, the ones with millions of followers, the system automatically switches over to the push method. This makes sure their millions of fans get the update quickly without slowing anything down for the rest of us. It is truly the best of both worlds. So we've designed the features, we've got the core logic figured out, but now we have to make sure our app is tough, that it's robust. We need to build it to last, and that means focusing on those non-functional requirements that guarantee it's secure, fast, and ready to grow to millions and millions of users. This number right here is a promise. 99.9% availability, or what engineers call 3 nines, means the entire system can only be down for about 8 hours over an entire year. That is it. For a global app that people are using 24/7, that is the absolute minimum standard. It just has to work. And achieving that kind of rock-solid reliability takes layers of defense. Strong password hashing basically puts your password through a one-way scrambler that can't be reversed. Rate limiting acts like a bouncer at a club, stopping bots and spammers for making too many requests. Caching keeps popular content in a super-fast temporary memory. It's like putting it on a nearby shelf instead of way in the back of the warehouse. And a CDN, a content delivery network, puts copies of photos and videos in servers all over the world so they load instantly for you no matter where you are. Every single layer here is critical. And here's one last clever trick for making things lightning fast: denormalization. Now, it sounds complicated, but the idea is actually really simple. Instead of forcing the system to count every single like on a post, every time it's viewed, which could be millions of times, we just store the total count directly on the post itself. It's a strategic shortcut, a little bit of data duplication that makes a massive difference in speed. So there you have it. From a simple question to a complete blueprint. We've defined exactly what our app needs to do, we've designed the architecture, structured all the data, and we've even planned out the most critical feature, the feed. The foundation is set. Now the only question is, with this blueprint in hand, what feature would you build next?